Okay, this is the reteach video for Unit 2, Test 1, Proportional Relationships. You do need to complete the entire video in order to retest. So even if you've gone through and only completed the problems that you missed, you do need to complete the entire Edpuzzle and hit submit at the end, as well as turn in your paper that you've done the work of the practice problems on. It's also a good idea to have your test out in front of you so you can see which problems you missed and which ones you need to be paying most attention to. And it is very important, it's come to my attention that some of you don't listen to the videos, you only watch them. You are not getting all the information you need unless you are also listening to myself explain it while I'm working on it. Watching is not enough, so you need to be listening through speakers or through headphones or earbuds as you complete the video. Problem number 1 talks about 8 bats eating 40 grams of insects in one night. Here's your clue that we're talking about a rate, and we're talking about, in fact, this rate or ratio, and we want to know now how many grams of insects 64 bats could eat in one night. So you have options here. You could find the unit rate by determining how much one bat would eat and then taking it out to 64 bats. You could make a ratio table starting with 8 bats and 40 grams and working your way with equivalent ratios until you got to 64 bats. The way I prefer is setting up my proportion table or my one table. I know I'm comparing bats to grams of insects in my rate, and the original ratio is 8 bats eating 40 grams. The question, or the new ratio that we're looking for, wants to know the number of grams 64 bats would eat. So I need to make sure that I'm setting up that table correctly. From here, I can either look for a scale factor and a multiplier I can use either horizontally or vertically, or I could use cross products, but I've already seen a nice scale factor going from 8 to 64. I know I can multiply by 8, and then I would do the same thing to 40 to get n. So 40 times 8 would be 320. So now I know that 64 bats would eat 320 grams of insects if the rate were to remain the same. In question number 2, a warehouse floor has a perimeter of 6,615 feet, and we want to know what that same perimeter of the floor would be in yards. So this is a measurement conversion. On the back of your test, you had your reference materials, and right here under length, customary length, we can see the relationship between yards and feet. 1 yard is equal to 3 feet. So I'm just going to write that near my problem. Again, my preference is using the proportion table. And I know this time I'm comparing feet and yards. The conversion from the back says that 1 yard is equivalent to 3 feet. So you need to make sure those numbers are in the right place. And the perimeter that was given is 6,615 feet. So I need to make sure that number ends up where feet is. And I'm looking for how many yards that'll be. So then I can notice, well, to get from 3 to 1, because I would have to go in this direction, to get from 3 to 1, I would divide by 3. So I'm going to divide 6,615. And if you use the bigger to smaller, smaller to bigger method, we are going from smaller to bigger. Feet are smaller than yards, so we would divide that by 3 to find the number of yards. Let's see, 3 goes into 6 twice exactly. going to go into 6 twice again. 3 will not go into 1, so we put a 0 placeholder. And it does go into 15, 5 times exactly. So 6,615 feet would be equivalent to 2,205 yards, which is answer choice F. Question 3 had some information above the picture. You had to make sure you read about the barrel. Really, 60 gallons of water being contained is reiterated down here in the bottom, but the whole thing contains 60 gallons. Water leaked out of the barrel at a rate of 5 gallons. There's that clue we're using rates. Okay, so 5 gallons every 3 days. Sounds like an original rate to me. Wrong way, sorry. And the last bit of information, we want to keep the rate the same, but we need to know how many days it will take for 60 gallons of water to leak out. So now all 60 are leaking out. My preference again is to set up a 1 table. And in the original rate, I can see that I'm comparing gallons to days. So those are the words I'm going to use. In the original rate, it's 5 gallons for every 3 days, so that would be the original ratio. And in my new ratio, I know I have 60 gallons of water that have leaked out. What I don't know is the number of days that it takes, so that's what I'm trying to find out. Here again, you have options. You could use cross products. But I know my times tables, my multiplication tables, and 5 times 12 is 60. So I can use that same scale factor across the bottom. 3 times 12 would be 36. 36 days, which is answer choice J. Sorry, there's my scale factor that you couldn't see. In question number 4, a robot's height is 1 meter 20 centimeters, and we want to know how tall the robot is in millimeters. So this is a conversion, a measurement conversion. We will look at the back eventually. But there's a couple things to notice. The original height that's given to you is given to you in 2 increments. And so in order to find that robot's actual height, we need to kind of put those increments together into one amount that we can then turn into millimeters. So right now I'm just going to worry about this. I need meters and centimeters. I need that down to one thing. So it makes the most sense to me to turn it into centimeters, because I know King Henry died. I forgot the Henry. King Henry died unexpectedly drinking chocolate milk. I know that this is centimeters, and it's right next to millimeters. My unit, meter, is over here. So I'm going to go ahead and take it from meters to centimeters first. In 1 meter, there are 100 centimeters. So that means this would be the same as 100 centimeters plus another 20 centimeters, which is a total of 120 centimeters. And now that I know I have 120 centimeters, I can turn those centimeters into millimeters. You can use the 1 table again. You can use your King Henry died unexpectedly drinking chocolate milk, dividing by powers of 10. I think some of us get a little confused still with that. So I am going to use my 1 table, comparing centimeters and millimeters. The original ratio comes from your conversion chart. So now we're looking at the relationship between centimeters and millimeters. For every 1 centimeter, there are 10 millimeters. So 1 centimeter is the same as 10 millimeters. And our robot's height we now know to be 120 centimeters. We need to find how many millimeters that is. Okay. So again, we can go from 1 to 10 with a scale factor of 10. So I'm going to do the same thing to 120. And when I multiply by 10, it moves the decimal point once to the right, which would be 1,200 millimeters. Same as answer choice A. Number 5, you were given ratio tables as answer choices, so you had to figure out which answer choice was correct. There we go. It was a little blurry. Alright, so to make pink paint, Sylvia mixes 7 cups of white paint to every 3 cups of red paint. So that would probably be the first thing I would check. Make sure that it's in that order: 7 white to 3 red, 7 white, 3 red, 7 white, 3 red, 7 white, 3 red, 7 white, 3 red. So they're all correct so far. Which table shows the possible values of white, or W, the number of cups of white paint, and R, the number of cups of red paint? So remember that equivalent ratios have to show a relationship through scale factors or multiplying. So like my attention is drawn right here to B, because if I think about going from 3 to 6, that would be times 2, and 7 to 10, 7 times 10 or 2, same scale factor, is 14, and that's not 14, so I can eliminate B. So now I'm going to come back up here and check this one. 7 to get to 49, that's times 7. But down here to get from 3 to 9 is times 3. And do you see how these scale factors are not the same number? They're not equivalent ratios then. On C, to get from 7 to 14, my scale factor would be 2. To get from 3 to 6, my scale factor is also 2. So far a good match. 7 to 21 would be times 3. 3 to 9 is also times 3. Looking good. Last one to check. 7 to 28 is a scale factor of 4. So as long as this works, 3 times 4 is 12. So C looks like the best choice. I'm going to go ahead and circle it, but I still need to check D. And D has a similar issue to B. One, you're never going to have equivalent ratios where one of the numbers is increasing while the other number is decreasing. That doesn't make sense. Okay, there's no way that can be a equivalent ratio. So we can eliminate D. On question number 6, Jose paid $47 for 4 movie tickets. Each ticket cost the same amount, and we want to know the cost of each movie ticket in dollars and cents. So basically I'm going from $47 for 4 movie tickets, and I want to find out how much one movie ticket costs. I'm finding its unit rate. So I can do that by dividing by 4 to get to 1 ticket. So I'm going to do the same thing on top. Divide by 4. Four goes into 4 once. 4 goes into 7 once. Sorry, that's a decimal. 4 goes into 30 7 times, that's 28. Remainder 2. Bring down the last 0, and 4 goes into 20 exactly 5 times. So each ticket then would cost $11.75. That's also one that you can check fairly easily. You could multiply $11.75 back by 4 to make sure that it was in fact $47. And it is, so I know I got my answer right. On question number 7. Question number 7, I would say, was one of the most missed because some of us didn't study very well when it came to converting between our systems. So if you notice, in this problem, we're talking about tons and kilograms. And tons are part of the customary system, where kilograms are part of the metric system. And that's why you won't find their conversion on this chart. They had to give you the conversion here in the problem. Now, what threw some of you off is this word approximate. But we talked about in class that this symbol means approximately. So if I see that symbol in my conversion, like it is here, and then I see the word that it means here, I don't get to round it. I cannot make this 2 tons or any other rounding. I already have an approximation in my conversion. So you need to work it just like you would a problem that had an equal sign. The approximate here comes from the fact that I can't get an exact measurement off of a number that's already been approximated. So I'm going to go back to what's worked so well this far. Set up a proportion table, and now I can see that I'm trying to turn tons into kilograms. So tons and kilograms are my words. The original ratio comes from this conversion. I'm not going to change anything. I'm not rounding any numbers. I'm using the information that was given. And the new information, I know I have 2.4 tons. What I'm looking for is how many kilograms that is. Okay. So this would be a time that you could use cross products, but we also know that 1 is a special number. 1 times anything is itself. So right here I can tell that I have to multiply by 2.4 to go from 1 to 2 4/10. So then I would do the same thing down on the bottom, which means I'm multiplying 907 2/10 by 2 4/10. And some of you got that far, and then you try to do a lot of work with dividing and all this interesting stuff. We've already talked about multiplying decimals this year, and you should know those rules. If you're still having trouble with them, that means you need to practice more at home, because we can all multiply this problem if we are in 6th grade pre-AP math. Multiplying decimals is the same as multiplying whole numbers. It starts the same. So 4 times 2 is 8. 4 times 7 is 28. 4 times 0 plus 2 is 2. 4 times 9 is 36. 0 placeholder. 2 times 2 is 4. 2 times 7 is 14. 2 times 0 plus 1 is 1. And 2 times 9 is 8. 18, I'm sorry. So now we add those together. 8, 12, 7, 7, 11, and 2. And now the only thing that's a little more difficult, and not even hard, but just something you have to remember about multiplying decimals. Once I've done that, I need to figure out how many numbers total I had behind a decimal point when I was multiplying. There's 2 numbers total, so I start at the right and move my decimal point to the left 2 times. That means the answer is 2,177 28 kilograms. But the best answer even would be putting this approximate sign in front of it, because we know that it wasn't exact to begin with. So our answer is an approximate weight. Notice I didn't do any rounding. On number 8, when buying bottles of apple juice, Ava spent $1.56 on a 12-ounce bottle and 90 cents on a 6-ounce bottle. You were supposed to use unit rates, which some of you ignored, to determine which bottle costs less per ounce. So yeah, there are other ways to determine if which one's the better deal, but this specifically asks you to use unit rates, meaning you were supposed to find out how much it would cost per ounce. And some of you didn't even read the question to begin with, so you need to take your time on these and really read carefully. So in order to find the unit rate, we're going to start with the 12-ounce bottle, which costs $1.56 for 12 ounces. If I want to know the cost per ounce, I'm trying to get that down to 1 ounce, which means I need to divide by 12. So I'm going to do that quickly. $1.56 divided by 12. 12 doesn't go into 1. It goes in 15 once. And it goes into 36 3 times. Exactly. Oops, sorry. So the 12 ounce costs 13 cents per ounce. The 6 ounce, on the other hand, costs 90 cents for 6 ounces. And I again want to find the cost per 1 ounce. So this time I'm going to have to divide by 6. And let's see, 90 cents divided by 6. I'm not going to go into 0. It'll go into 9 once. Remainder 3. 6 goes into 30 exactly 5 times. So now I can see the 6 ounce bottle actually costs 15 cents per ounce, while most people for the same product would want to spend 13 cents over 15 cents. They'd want to save those pennies, especially the more ounces you buy. So the 13 cents per ounce or the 12 ounce bottle is the better of the two. So your answer needed to say something along the lines of the 12 ounce bottle is the better buy, because it is 2 cents less per ounce. Something along those lines. That explains why you think the 12 ounce bottle is better, and you should have had those unit rates correct as well. On problem number 9, we're determining which of the following shows the possible numbers of boys to girls in the school musical. And they gave us an original ratio of boys to girls being 5 to 8. So this is where order really matters. In fact, I would recommend on this one just making yourself a ratio table. I rarely recommend it, but this one, because you have options for the answer choices, you need to figure out which one's correct. I think the ratio table is the way to go. The order of the original ratio is boys to girls. So I'm going to put boys on top, girls on bottom. This number ratio is exactly the same. So since boys were listed first here, 5 goes to the boys. And 8 second, or after the word 2, so 8 is how many girls there were. Now, I've got a couple of combinations here that I see, so I'm going to just kind of fill in my table. If there were 10 boys, there would be 16 girls. If there were 15 boys, there would be 24 girls. Okay, I'm just increasing by the same scale factor. Here the scale factor was 2, here it's 3. There I can actually check an answer because I found how many girls there would be for 15 boys, just like this says, and it's 24, not 32. Okay, so I'm going to keep going. Here I have 20 boys, and that would be 8 times 4 is 32. Well, now I can check this one as well because this says there are 20 boys, which I just made it to in my table, and 32 girls. That's correct. But I'm going to go ahead and make sure, well, now I can get rid of this one. But now I'm going to make sure that this one is not also correct. And actually, I can tell right now that it's not, because there are less girls than boys in this one. And there's always less boys than girls. So I can actually eliminate that answer choice as well. And C would be the correct. You got to pay attention. A lot of you picked A, But this was girls and boys, different order. And when I get to 30 boys, that is correct. So here's 25, which would be 40. And here's 30 boys and 48 girls. But again, those words are backwards. And you should have come to this one first. So it's a little confusing how some of y'all made it to that one. Alright, the last problem talks about Caroline's cell phone plan that costs her $32 per month. So there's a rate right there, a unit rate, $32 every month. We want to know which table shows the sum of the amounts that Caroline will pay for her cell phone plan over the next 4 months. So if every month she's paying $32, then the first month she can't be paying $0. Got to get rid of that. Still true, the first month she can't be paying $8. They just told us that she paid $32 a month. So I'm going to get rid of that. Now I have two answer choices where the first month is in fact $32. When I go to the second month, I now have a scale factor of 2. 1 times 2 is 2. So that means here I should have a scale factor of 2 as well. Well, 32 times 2 is 64, and this is definitely not 64. So I can eliminate that answer choice, and the correct answer choice then is J, where I do see using a scale factor of 2, I would get 64. Using a scale factor of 3, you'd get 96. And finally a scale factor of 4. Is 128. Make sure again that you complete the whole video. You've answered all the questions in the Edpuzzle, and you're turning in your paper where you answered your extra practice problems to your math teacher.